All right, so what we were going to do yesterday in a lab was to look at behavior that is known as Boyle's Law. Actually, I think the print. Yes, this is Unit 7. Actually, that print that goes on the outside there, not inside, because Boyle, his name. No, that's right, because it's Robert Boyle. Okay, it's Charles that I put the Charles Law. Put that thing on the outside. Okay, Boyle's Law. All right. So Boyle was looking at the very behavior that I was going to have you guys look at in the lab yesterday that had so much difficulty getting started because so many people didn't have their procedures done, or so many people were out or coming in late that we just get it done. Okay, so we're not going to go back and do it again. Um, so what Robert Boyle back, man, how long has it been? 200 years? 300 years? Anyway, he was examining the behavior of gases. And what he found was that if you multiply pressure times volume, you get the same number, or virtually, or very close to the same number every time. And as long as the gas is contained, that is, you don't put any extra gas in there, you don't take any gas out, and you don't change the temperature, okay, you see the same amount of gas and don't change the temperature. So you've got the gas contained in something, so it can't get out. If you change the pressure, the volume responds, so that you always have the same number if you multiply them together. If you change the volume, the pressure is going to change, so that you multiply them together, you always get the same number. Does that make sense? Okay. So what that means is if I start out with one measured volume and one measured pressure for a gas, that's going to equal K, that constant. And if I change the pressure, there's going to have to be a change in the volume, so that also equals K. And if I change it again, that's also going to equal K. And if I change it again, and so forth and so on, that's going to equal K. And so when you did if you had done the lab yesterday, if you had graphed your results, you would have found a relationship that looked like this. And that's called an inverse relationship. So that was the pre-lab quiz we did yesterday, where you were supposed to identify a direct relationship and an inverse relationship. This kind of relationship is called an inverse relationship. What? Is a constant. So it's like you take x and multiply it times y, and you always get the same number every time. That's what a constant is. A constant is the same number that you get all the time. All right? And in this case, x is p and y is v. But any relationship between two variables where you multiply those together and you always get the same number, change x, y also changes, you always get the same number, that's called an inverse relationship. Okay? That pattern is called an inverse relationship. All right? So what this means then is P1 times V1 is also going to equal P2 times V2, which is equal to P3 V3, and so forth. Okay? And that gives us a really simple mathematical relationship that allows us to solve some pretty simple problems. So gas held in a cylinder under a piston that has no friction, no temperature change, if the pressure is 2.50 atmospheres, ATM stands for atmospheres, and has a volume under that piston of 25.5 milliliters. Atmospheres. There's like 4 different units of pressure measurement that you're going to have to know about. You don't have to figure them out. You don't really have to convert them, but you have to know about them. Okay, the conversion is actually in your test references, and we'll get to that. Okay, and the piston is, let's say it's compressed. So that the volume becomes 12.25 milliliters. What will the pressure be? Anybody taking auto repair at R.D. Anderson Vocational Center? No? Well, this is compression inside a cylinder. That's what we're talking about here. Okay? That's exactly what's going on. So you spray gasoline in the ignition chamber. You have air in the ignition chamber. Then you compress it with a piston. Then you put a spark in there, and it pushes the piston up again. Okay? So we're basically describing part of that process here. Okay? How do you get compression? That's it right there. All right. Here's how we're going to solve the problem. And every gas law problem we solve will be solved the same way. Are you listening? Every gas law problem that we solve will be solved in this way. Okay? Number 1, you're going to make a list of all your knowns and unknowns with the appropriate symbol. Works like this. Reading through the problem, and oh, there is a measurement. Okay? Well, that measures the pressure. It tells me that. Now, later in this unit, you should know if it says 2.50 atmospheres, you should know that's pressure. Okay? You'll become familiar enough. You should become familiar enough. If you're paying attention and doing your work in here, you will be familiar enough with these units of measurement to know that that's one of the ways we measure pressure. Okay? So we're going to say that's pressure using that symbol, P, and say that pressure is 2.50 atmospheres. Okay? Then we're going to look through here and read. Oh, here's a volume, 25.5 milliliters. V is 25.5 milliliters. Okay? Read. We said the piston is compressed, so the volume becomes, well, this is a new volume. Okay? So this must be the first volume, and this must be the second volume we're talking about here, that we're getting to 12.25 milliliters. Okay? And then we read, and it says, what will the pressure be? Should put a question mark there. Okay? Well, that means we need a second pressure, and we don't know what it is, so I'm going to put that question mark there. Okay? Pressure 2 is question mark. All right? So I have pressure 1, volume 1, pressure 2, volume 2. I know which equation to use. It's right here. Okay? So I'm going to list the equation I'm going to use here. P1 equals P2 V2. Okay? Because there it is. There's the variables right there. There's the equation that fits those variables. Boom. It's not that hard. Hey, pay attention. Here's a list of variables on the left side. Here's an equation right here that fits those variables. That's the equation. It's not that hard. Yeah. I understand what it's doing, but you just need to pay attention.
We just can't see where you're pointing at whenever you're trying to...
Can you read the paper?
Yeah.
Okay, good. All right, it's right there on the paper. All right? It's right there on the paper. Here's your list of knowns and unknowns. There's your equation. Okay? Got it? So you're going to make a list. You got something to say, Evan? Okay. All right. There's your equation. That's your list of knowns and unknowns. It's not that hard, folks. Okay? We just list it. But you do have to list the proper equation. Have to do it. Okay? Now you're going to substitute known values. Well, what's P1? What's the known value for P1? Right, 5 at, and then we're going to multiply that 2-point atmospheres. Guys, write it down. I'm sorry, you can write it down. You don't have to have your hands held. Write it down. I know, but it's not you. It's not you, Patrick. Come on. We all. All right. I understand. Okay. What's V2? What's V1? Put it down. Yeah. That's fine. It actually means to, but you have to get to pretty high level math to know that. Okay. Okay. All right. Do we know what P2 is?
Yeah. No.
Then you don't change it. Just write P2 down after the equal sign. Okay. Do we know what V2 is? Write it down. Yeah, it is. All right. Yes, you do. It is exactly like math. Now listen, we're going to listen. We're going to write down a list of knowns and unknowns. We're going to write down the appropriate equation to fit those. Then we're going to substitute known values for the variables. Now we're going to solve the problem. Now listen to me, there's a very specific way that I expect you to do that. Okay? The next step is to isolate the unknown. What does isolate mean?
Put it by itself.
Put it by itself. What mathematical operation do I need to use to get the unknown by itself? Divide by what? Alright, so I'm going to divide by 12.25. Now if I do it to this side, what? You got to do it to the other side. There you go. Yeah, it isn't hard. It's just basic algebra. You've been doing this for years now.
Because you're using milliliters, how do you divide the atmosphere by milliliters? Or do you leave it alone?
This is the same as that. The whole thing cancels. This is the same as that. Those two cancel. What are you left with? You don't have to divide by atmospheres. You just do the math. Okay? Get out your calculators and let's find an answer. Get out your calculators, let's find an answer. You should be practicing each time we do these so that you get better at this. Well, it's not 5.2. It's 5.204. 081 633, or you may have a couple of extra less digits than that. That's okay. What units of measurement belong with this number? Atmospheres. And that equals P2. And then we're going to round off. And we need 3 digits, so it's 5.20. Okay? Does that make sense? You don't remember how to do that? We've been doing it all year. 3 digits, and 4 digits. Which one has the least digits? You match your answers, digits, with the measured or calculated number that has the least digits, okay? All right. Homework problem. I'm not going anywhere. We'll turn it in tomorrow. Then you're going to turn in the next day. Whatever next day you're here, you'll turn it in.
Are you serious? But being, I gotta give my laptop back. So I just come out of school this turn in my own practice. I just want to see if he does it.
I suggest you write so you don't have to stay after the bell rings. Oh, sorry. That's my fault. I apologize. Millimeters of mercury is another pressure unit. Millimeters of mercury is another pressure unit. Okay? .0 millimeters of mercury. What will the volume be? Okay, so you're going to have, yes, I gave you a little extra homework this time, but it's not so much that you can't do it if you got 3 days to do it. mmHg, millimeters of mercury. mmHg is millimeters of mercury. I will draw your attention, if you will pay attention, to the front page of your test references. And on the front page of your test references is a list of pressure units listed for standard pressure. Okay? So we've used so far atmospheres, and tonight you're using, or this next couple of days, millimeters of mercury. We've also got torr and kPa to deal with. Okay? But if you want to know what the pressure units are, there they are. All right, guys, y'all have a good couple days. See you back here.